Hello everyone, now let us see properties of state transition matrix. With the help of properties of state transition matrix, we can easily calculate state transition matrix for different problems. State transition matrix possesses the different properties. Now let us see what is the first property. Phi of 0 equal to identity matrix. Now let us see how it is possible. We know state transition matrix is denoted by phi of t, and we know phi of t is e to the power at. Let us put t equal to 0. So we have phi of 0 equal to e to the power a into 0 or 1. 1 means identity matrix, because here phi of t will also define the matrix. That's why one will define identity matrix. So we can say phi of 0 equal to identity matrix. Now let us see second property. According to the second property, phi inverse t equal to phi of minus t. Now let us see how it is possible. We know state transition matrix is given by e to the power at, or phi of minus t is given by e to the power minus at. Suppose this is my equation first dash and this is my equation first. Now let us post multiplying by e to the power minus at for both sides of equation first dash. Because here we are dealing with the matrix, that's why I am saying post multiplying of both sides of equation first dash with e to the power minus at. So we have equation phi of t e to the power minus at equal to e to the power at into e to the power minus at. So we have e to the power at into e to the power minus at means identity matrix. So phi of t e to the power minus at becomes I. Now let us see how we can prove the relation. Now pre-multiplying both sides by phi inverse t. So we have phi inverse t phi t e to the power minus at equal to phi inverse t into I. Here we are multiplying both sides of equation 2 with phi inverse t, and we are dealing with matrix. That's why we can say here we are multiplying both sides of equation 2 with phi inverse t. That means pre-multiplying both sides by phi inverse t. So we have phi inverse t, phi t e to the power minus at equal to phi inverse t into I. So we have after simplifying e to the power minus at equal to phi inverse t. Suppose this is my third equation. So if we compare first and third equation, so from first and third we can say phi of minus t equal to phi inverse t. So from first and third, we can say phi of minus t equal to phi inverse t. Hence proved. Now let us see third property. So according to the third property, phi of t2 minus t1 into phi of t1 minus t0 equal to phi of t2 minus t0 for any t0, t1 and t2. For any time instant t0, t1 and t2. Now let us see how we can prove. We can write phi t2 minus t1 into phi t1 minus t0 equal to e to the power a t2 minus t1 into e to the power a t1 minus t0, because we know phi t is e to the power at. So we have e to the power a t2 minus t0, or you can say phi of t2 minus t0. That's why we are saying a phi t2 minus t1 into phi t1 minus t2 equal to phi t2 minus t0. This property of state transition matrix is called the transition property, and it implies that a state transition process can be divided into a number of sequential transitions. Now let us see. Let us try to understand according to the diagram. Suppose we have time instant t0, time instant t1, time instant t2. And here we have x t0, here we have x t1, and here we have x t2. Between t0 to t1 we have a state transition matrix phi t1 minus t0, and between t1 to t2 we have a state transition matrix phi t2 minus t1. If we see overall from t0 to t2, we can say we have a state transition matrix phi t2 minus t0. So from the diagram we can say transition for t equal to t0 to t equal to t2 is equal to the transition from t0 to t1 and then from t1 to t2. So in general we can say state transition process can be divided into any number of parts. Now let us see fourth property. So according to the fourth property, phi of t power k equal to phi of kt for positive integer, where k will define a positive integer. Now let us see how we can prove. Phi of t power k equal to e to the power at into e to the power at up to e to the power at. That means we have k terms. So we can write it as e to the power k at, or we can write phi of kt. That's why we are saying phi of t power k equal to phi of kt for positive integer. Now let us see last property. So last property is phi dot t equal to a phi of t. Now let us see proof. We know state transition matrix is denoted by phi of t. It is e to the power at. So let us differentiate phi of t with respect to t. So we have phi dot t equal to a e to the power at. It is equal to a phi of t. That's why we are saying phi dot t equal to a phi of t, where phi dot t will define first derivative of phi of t. So we have total 5 properties of state transition matrix. With the help of properties, we can easily define the state transition matrix. And already I have told you what is state transition matrix. So thank you. And in next video class, we will discuss transfer matrix, solution of state equation, and last topic, controllability and observability of control system. Thank you.